to Coulomb, 8 times 10 to the power of -9 coulombs. And then this is -3, so -3 times 10 to the power of -9 coulombs. What we know about units, number one, if you have 1 mc is equal to 1 times 10 to the power of -3 coulomb. Or if you have 1 micro coulomb is equal to 1 times, you can use any of these, even dot or cross is fine. So -6 coulomb. And then if you have 1 nc equals 1 times 10 to the power of -9, what we are using for this question. And then 1 pc equals 1 times 10 to the power of -12 coulombs. So you have to remember these units. And then unit of distance always in meter. So 12 centimeters is equal to 0.12 meters divided by 100, as you know. So this one also divide by 100. So this is our question. And then this is our just points what we have to remember for this question. And then what was the another important point for electric field? Positive always repel. So it is positive Q1. So E1 repel point A. So direction of E1 to the right. This is direction of E1. When we start answering questions, also we are going to draw free body diagram. But for now, just let's show. We never start answering questions. For now, we are just showing what we have to do before you start answering questions. You must convert units, and then you must show direction for electric fields. What about E2? It is negative. What we know, negative always attract point, just attracting electric field. So to the left, this is our direction of E2. I hope everything is fine. From now, we are gonna calculate what formula we are using, people. E1 or E is fine. We are using K times Q1 and R squared. So R is distance from that charge to that point. And then K is constant number. K is 9 times 10 to the power of 9. We know this constant number. So, okay, you remember all. From now, we can carry on. We can answer our question. I hope you did try. I hope you got correct answer already. Let's see. This is our answer. You will get this answer when you calculate it. How we are going to get it, let's explain. So, first of all, we are drawing free body diagram. This is our first point, first step, point A. Q1, making E1 on A, so to the right. How we know to the right? Because positive always repel. So repel point A. Just forget about Q2 for now. This is for this position. You have Q1 and point A. And what about your distance? 20 centimeters. Please remember that. When you calculate E1, you are going to use 20 centimeters because distance between Q1 and A is 20. So this is our E1. And then what about E2? Now you have Q2 and distance, as you see, is 8 centimeters. 8 centimeters is there. So point A and direction, it is negative. So just attracting direction of E1 to the left. I hope everything is fine so far. What we are doing, we are drawing our free body diagram. From now, what are we going to do? We are going to calculate E1, E2, and then getting net electric field. Let's calculate E1. E1 is equal to K times Q1 over R squared, R1 also you can say, let's say R1 is fine. And then 9 times 10 to the power of 9. And what's our Q1? What's it? 8 NC. We know 8, we convert already. 8 times 10 to the power of -9. And then distance is 20 centimeters. You know 20 centimeters is equal to 0.2 meters. Divided by 0.2 meters squared. So you are just calculating like that. And what is our E1? When you calculate, you are getting 1,800 newtons. This is our E1. I hope it's okay. Now we are calculating E2. let's get different color. E2 is coming now by using same formula, KQ2 now, and R2 square we are using. K equals 9 times 10 to the power of 9, and Q2 is what we have 3 times 10 to the power of negative 9. We are not using negative. Please remember that. We are not using negative, just negative, positive, helping you to get direction of electric field. And what we have 0,08 because it is 8 centimeters. When you convert it, 0,08 meters you are getting. So this is our E2. When you calculate it, you are getting 4,218,75. But we wrote the wrong unit. What was the unit of electric fields? We wrote unit of force by mistake. Let's fix it. Unit of electric field N times C negative 1. So we can write Newton times Coulomb power of negative 1. So this is our E1 and E2. From now, what are we going to do? We are getting net electric field with direction. E net equals, what is first? E2 or E1? Let's see which one is bigger, which one is more. As you see, E2 is stronger than E1. So we can write E2 minus E1. E2 is equal to 4,218,75 minus, we are calculating, minus 1,800. And your answer is 2,418,75 N times C negative 1. It was answered here. So direction to the left, direction to the stronger one. As you see, E2 is stronger than E1. Direction is going to E2, to the left. I hope everything is fine. If you have any question, you can ask me. So this is our answer for question 1. Today's question 1 we have done. Let's continue with next question. Question 2 is coming now. Question 2. Calculate the net electric field and direction on point A. Let's continue with question 2. So calculate the net electric field at point A. We have Q1, Q2. What's the difference between question 1 and 2? Question 1, E1 and E2 opposite each other, so you can subtract them and you can calculate. But now they are coming with angle. We will see now with our solution. I think we have solution now. Yeah. First of all, we are drawing our free body diagram for this kind of questions. Let's see, as you see, E1 to the left, E2 to the, just is going down, south. So how it's happening, just let's explain on our diagram, force diagram we can draw, or vector diagram we can say. So E1, it is positive. If it is positive, what we know, repel. So repelling point A, if it is repelling, so of course going this way. So this is our direction of E1. And then E2 also positive, so going this way. When you calculate all, you are gonna use our formula. So E net equals, so using this one, E net. E net square equals E2 square plus E1 square. This formula we are using now. We are not just adding or subtract. We are using this formula to calculate E net. So I hope everything is fine. So same formula we are using. E1 is equal to K times Q1 over R1 square. And then K is 9 times 10 to the power of 9. Q1 is 2 times 10 to the power of negative 9. And 0,3. As you see, we are converting units. Please don't forget to convert unit from centimeter to meter. 0,3 meters. Unit of charge always in coulombs. So 2 times 10 to the power of negative 9 coulombs. So this one also same, 2 times 10 to the power of negative 9 coulombs. You are calculating E1, E2, and then using this formula, 200 each. And then finally, you are getting 282,84 n times c power of -1. Southwest, you can see direction for E net. I hope it's okay. This is our question 2. Let's continue with question 3. Similar question is coming now. Let's clear all, and then let's continue with next one. So calculate the net electric field strength and direction at point M. Same process, people. Just we are using same thing. But what we have now, which direction, that's important. Let's go to next page and let's explain with you. So first of all, I'm not waiting for you to answer question because you have done already. I believe you have done already. You download our worksheet and then you have done. Now you are just checking, correcting your answers. Please do that. If you want to learn, you should do that, people, not just listening and no, you cannot learn like that. Please get our worksheet from link and then you can try. After that, check all solutions. All right, please do that. So now what we have, you have Q1. Where is E1? It is positive, so repel this way. Sorry for drawing, but it's this way, E1, because repel M. So if it's repelling, if attracting, going up, but now going down. And then it is negative. So negative is attracting. So we have E2 this way. Now we can draw our free body diagram. It is our point M. First one, E1 this way, and then we have E2 this way. We have done. From now, what can we do? E net we can show, direction of E net we can show, just drawing parallel to each, and then direction of E net one more time. What's our direction? But the same direction, right? Just like other question, southwest. Southwest, E net. From now we can write our direction. Okay, it's fine. From now, what are we gonna do? We are calculating E1, E2, and then using this formula, E net square equals E1 square plus E2 square, and then you are getting E net by using this formula. Let's calculate E1. E1 equals K times Q1 over R1 square. So what is our K? 9 times 10 to the power of 9. And then Q1 is 3 times 10 to the power of -3. Why? Because we have MC. 3 times 10 to the power of -3. Bell ring, but not for you. We almost done. So R1 equals 0,3 meters. You are calculating. And then what's our answer now? 3 times 10 to the power of 6 unit n times C -1. And then E2 equals K times Q2 over R2 square. And then we carry on with 10 to the power of 9. And then what we have another one also 3 times 10 to the power of -3, because also MC, as you see there. And then 0,2 square we have. And our answer is 6,75 times 10 to the power of what we have 6, 10 to the power of 6, n times C -1. So we can carry on with E net. E net equals, E net square is equal to E1 plus E2. And then E1 is 3 times 10 to the power of 6 square, and then plus E2 is equal to 6,75 times 10 to the power of 6. And then when you calculate all, of course, you are making square root for that. So you are getting final answer 7, okay, we got calculations wrong, sorry about that. 7,39 times 10 to the power of 6 n C -1. This is our E net, not E net square anymore. So, and the direction southwest. We have done for today. I hope it's helping you. So if you have any question or comment, you can just ask me, and then I will try to help you. Good luck for your test, for everything. Thank you very much. See you next lesson with our lesson 5.